All right, so 8-2-1 is called trigonometric ratios. So this word, trigonometric, obviously comes from trigonometry. Ratios is all what chapter 7 was about, right? When we wrote most of our ratios as a fraction, something compared to something, okay? So the trigonometric ratio is what is a ratio of two sides of a special kind of triangle. Anybody want to guess what kind of triangle? How about the right triangle? Okay, so on a right triangle, you're going to take two sides of it and you're going to create a ratio. All right, so we're going to start by drawing a right triangle right here. And we're going to label the vertices, A over here, B up here, C is going to be our right angle. And then opposite each of those three angles, we're going to put their little letters. So opposite angle A, we're going to put little letter A. And then opposite angle B, this side over here, we're going to call little letter B. And then opposite angle C, on this side, we're going to put little letter C. Okay? So the three trigonometric ratios have fancy names. The first one is called sine, spelled S-I-N-E. The second one is called cosine, C-O-S-I-N-E. And the third one is called tangent, T-A-N-G-E-N-T. Okay? The good news is that all three of these words have shortcut words, and you may have seen them before on your calculator, right? Okay, so if you have a nice little scientific calculator, or you're using one of my calculators, you may have seen what looks like the word sin. It is not pronounced sin. It is actually pronounced sine. S-I-N is just short, a three-letter abbreviation of sine. So when you say it, you say sine, not sin. We're not a church, right? So you say sine, and then cosine is just going to be C-O-S, and then tangent is just going to be T-A-N. All right? Today we're not going to do any of these on the calculator, but we will on Tuesday when we come back. All right? So here's how the ratios work. If you are asked to find the sine of angle A, okay? If you look at the drawing we just did, angle A is not the right angle. It's one of the other two, okay? So the sine of angle A is going to be a ratio. And in that ratio, you're going to put the value of the opposite leg over the value of the hypotenuse. In this particular triangle, from angle A over here, the opposite leg is going to be this little letter A, and the hypotenuse is the little letter C. When you see them on your assignment, there's actually going to be numbers there. Okay, for right now, we're just doing the algebraic representation of it. All right, and so you might be asked to find the sine of A, or you might be asked to find the sine of B, which has the same ratio, the same opposite over hypotenuse. But now you switch angles. So instead of starting from angle A, you're going to start over here at angle B, and this time the opposite side is little letter B, and the hypotenuse is still C. So notice that the sine of A is A over C, and the sine of B is B over C. Just depends which angle you start with. Okay, they're going to direct you to a certain angle, go to the angle they tell you to go to, and then find the side that's opposite. The hypotenuse is always going to stay in the same spot, right? Because you can only have one right angle in a triangle, and so the side opposite of it, that number will stay the same. Okay, so that's the sine. Then you're going to be asked to find the cosine of angle A. And cosine has a different ratio. Its ratio is the adjacent leg, let's spell that correctly, over the hypotenuse. All right, so on this particular triangle, the address tells you to go to angle A. So the cosine of A says to find the adjacent. The adjacent is the one that's right next to it that's not the hypotenuse. So right next to A, we have the hypotenuse over here. So it can't be that one. It has to be the other one, which is B, over the hypotenuse, which is C. And these should be two different numbers, right? If you end up with this 7 over 7, you probably didn't get the adjacent side right. You probably accidentally went to the hypotenuse. Okay? Let's look at the cosine of angle B. So now we switched angles, and the adjacent side to B is the one right next to it that's not the hypotenuse, so it can't be C, it has to be A over C. So there's sine, there's cosine. Let's look for the third one, which is called the tangent of A. So the tangent is going to be the ratio of the opposite leg over the adjacent leg. So from angle A, the opposite leg is the A, little letter A, and the adjacent leg is the little letter B. For that one, you don't use the hypotenuse. And the tangent of B would be the same ratio just from the other angle. So from B, the opposite is little letter B, and the adjacent is little letter A. So it's going to be B over A. Whoop. Let's shrink that down and move it up a little bit. Notice that we only used angle A and angle B. All right, for trigonometric ratios, you don't use the right angle, the one that has the 90-degree symbol on it. You just use the other two, which are both less than 90 degrees, okay? All right, so one of your tasks today is to memorize this ratio of sine, cosine, and tangent. So there's a little shortcut that I learned when I was in high school. Okay, it's called SOHCAHTOA. And so the sine is opposite over H. So you pronounce that kind of funny. You say so, and then the cosine is AH, ka, and then the tangent is opposite over adjacent, toa, SOHCAHTOA. Since then, another teacher made one that was funnier, okay? And if you can just remember the order sine, cosine, and tangent, and you don't use the S, C, and T, you can use this funny one. It's old hippies are high on acid. See, I don't know, most students remember that one way easier than SOHCAHTOA because it's funny, right? You just have to remember the order of sine, cosine, and tangent, which is how it comes on your calculator, okay? So if you're taking a test, you can just write, oh wait, old hippies are high on acid, or just write it on your note card. All right. So one of your assignments today is you're going to make up your own mnemonic device. You're going to create your own silly little sentence. It's going to be school appropriate, and you can't use either of the two that I just told you. You have to make up your own, okay? All right, so let's look at how you're going to use this. So you're going to draw a right triangle. We'll call this one JKL. We'll put the right angle right there. Let's label some sides. We've got 11 inches over here on JL. We've got 60 inches over here on KL, and we've got 61 inches over here on the hypotenuse. Okay? So the first problem we're going to do, we're going to use this same drawing for all three. We're going to find the sine of J. Okay, so this is kind of like your address. Okay, so sine is old hippie, so you're going to say O over H, so opposite over hypotenuse. And in this case, you start at angle J. So here, you put your finger at J, and you'll go, okay, opposite angle J is what number? 60. So you fill in 60. And then the denominator, or the other part of the ratio, should be the hypotenuse. And you come over to the hypotenuse, and you get that number. What is that number? 61. Okay? That is called your ratio. So if they say, what is the ratio of the sine of J? That's your answer. It's pretty easy, right? All right, example number 2. Now I want you to find the cosine of K. So you're going to go to angle K, and you're going to remember that the cosine is R high, so start with A over H. So A stands for adjacent, H stands for hypotenuse. So from angle K, the adjacent is the one right next to it, so 60, over the hypotenuse, which is 61. Notice that the answer to example number 1 is the same as the answer to example number 2. That's okay, right? Because we started with different angles. And at some point, you're going to have repeating things, okay? The third one, example number 3, we're going to find the tangent of angle K. The tangent is the ratio of on acid. So opposite over adjacent. You take your finger and you move over to angle K. From there, the opposite, the number there is what? 11. And the adjacent is what? 60. So 11 over 60.